About my Cowboys because they didn't win. It is what it is. You know? I was there at the game yesterday. Watched them lose live. It was horrible. But that's okay because it's still basketball, hockey, and then baseball season coming up. And then we have our San Antonio Brahmas, so we're gonna have fun talking about more sports, right? Of course. Yes. Now, like I said, we're in Unit 5. I should have said, I think, Unit 5. We're talking about exponential graphs. By the way, New Year, same rules. So there's no headphones, please, while I'm talking. We will have a quiz next Wednesday, so don't get. It's not this Wednesday. You know, we'll learn the stuff before then. It'll be good. All right. We're also going to be doing some stuff on computers with this stuff called Mastery Prep, which is going to help us hopefully prepare for that STAR test. Okay. Everyone should have written down 2 sentences. Don't forget the top blue sentence. Okay. So there's always 2 parts to these warm-ups. Here, you want this? This is what you're going to turn on, brother. There you go, William. So don't forget this top blue sentence. That's 5 points. The warm-up 15 points, 20 points a day times 5 is 100. You get 100 every week, right? Okay, so that's it. Now I'm going to show you a little video. 1 second. All right, watch this.
It's not really a big deal. They don't even walk that fast. And anyway, even if there was a zombie apocalypse, I reckon you'd have ages to get out of the way. And I reckon I can prove it with some maths. Let's say we had some zombies who weren't especially greedy, so that each zombie infected 1 healthy person every day. Now, unless you're going to arm your entire country with chainsaws, clearly the most balanced weapon of choice in a zombie apocalypse, we can make the assumption that everybody is susceptible to a zombie attack. So if you started off with 1 zombie, on the first day, they'd infect 1 person, so there'd be 2 zombies. The next day, they'd infect 2 zombies, so there'd be 4, then 8, then 16, then 32, then 64, and then 128. 128 zombies after 7 days. What are all these films going on about? But actually, if something is increasing by a fixed fraction in a fixed time window, so doubling every day, you can use an exponential equation to tell you what's going on. So in our case then, the number of zombies equals 2, because they're doubling, to the power of d, the number of days. And this equation then tells you quite quickly that after 2 weeks, there'll be 16,384 zombies. After 3 weeks, there'll be 2,097,142 zombies. And after 26 days, there'll be 67,108,864 zombies. And everyone in the UK will be dead, apart from maybe the people who had chainsaws. And actually, these exponential equations grow so fast that it would only take 33 days for the zombies to spread over the entire world, leaving everyone who is alive as dead. That's just over a month from now. Okay, Hollywood, I take it back. I'm going to go buy myself a chainsaw. Now,
all right, of course, none of this is real, so no one is hurt by this. This is all hypothetical, not real, and all that good stuff. So today we're doing a thing on zombies, okay? And we are talking about, we are previewing this little unit on exponential functions. Okay. Test this out. There's an extra one. All right, so check this out. Leading up to this moment, last year, the first semester, which was part of 2024, before we got back from the break, we were doing linear equations, straight lines, okay, like this. Like, the real question was, what's the slope and what's the y-intercept? There's only 2 things involved, right? Well, now we're getting into a new function called exponential, and instead of being straight lines, we're talking about these curved lines that are exponentially growing, okay? So like the video had with the nice British lady, she was talking about a zombie apocalypse, okay? And I want you to see two situations here. So I'm going to talk through this, but you're going to fill it out, and then at the end of class, we're going to go over it, okay? Now, the background is there are two strains of a zombie virus that have been discovered in the United States. Each strain is described here. So you have strain A, strain B. Now notice, strain A, it says each minute the original zombie infects 3 new people, but the new zombies do not infect anyone. They cannot infect anyone, okay? So I want you to notice, this is just adding 3 new zombies every minute, okay? So this strain A is an adding situation. All we're doing is adding. And that was the first semester in Algebra 1. We're just adding each time. That is linear equations. Y equals mx plus b stuff, okay? But strain B, what we're going to be talking about this unit, this strain B says each minute every zombie can infect 1 person, and the new zombies can infect people as well. Basically, that means the number of zombies are doubling each time. So when you're doubling, you're not adding each time, you're multiplying each time, right? Does everyone know that's what doubling means? Times 2 every time? Okay, so you could make a prediction, and I want you to in that rectangle right there. Which strain do you think is going to have more zombies after 10 minutes? So it seems like strain B is only like, there's only 1 being added each time, but it's by even the new zombies. The original strain A is adding 3 each time, right? So which one do you think after 10 minutes, without doing any math in your head, just kind of making a hypothesis guess, do you think strain A will create more zombies after 10 minutes, or strain B? It's up to you. You can write that in real quick or think about it for a second. But here's where you're going to do some work, okay? You're going to tell me, okay, through this table, the data, okay? So here's the deal. Strain A, and this is important. You don't start off with 0 zombies. I know, like right now, in this world, there are no zombies, or are there? But in this world, you have to have a starter zombie. So go ahead and make sure you put 1 as your starter zombie at 0 minutes for both of them. But here's the difference. Strain A, like we said, okay, you're adding 3 each minute, right? And then strain B, you are doubling each minute, okay? Times 2. Everyone know that's what doubling means, okay? Okay, so you fill that out. So, I mean, just to help you out with the first minute, if you just add 3 to 1, what do you get? Everyone should know this. I know you like the shot, but it's 4, right? You add 3 to 1. But on the other side, when you're doubling 1 zombie, now you have 2 zombies. And then after that, you double it times 2 times 2 times 2, okay? I'll see if you can fill that out correctly on your own. And then you got to be careful on the backside, because then you need to graph this thing. I want you to notice your y-axis is a little bit different. So look at these numbers carefully when you're plotting that table. And then we're going to get to the type of function, the strain equation, and if you get that far and you're like wanting to challenge yourself, you can try to figure out which or how much time it would take to get to 67,000 people, okay? The extension is if you finish and you feel like challenging yourself, but I just want you to get up to the type of function. What are the 2 types of functions? If you look at the title of this worksheet, okay, there's linear or exponential, adding or multiplying, okay? So again, if you can get right here to type of function, that'll be good. Last, if you finish that, hang out, and then near the end of class, we're going to go over it and talk about the strain equation, and that's our little preview before we really get into the notes tomorrow. Cool? Easy day. So, did your zombie tables look like this, where you were adding 3 each time here and doubling each time here? Okay, so look at the bottom of your table. You should have got to 22 on your strain A and 128 for your strain B after 7 minutes, okay? So that was your table, and then you were supposed to graph that. So when you graph it, this is what it should look like. Now, if your graph looks weird, maybe if it was your table, that makes sense. But for your graph, your y-axis is a little different for each one, so it'll fit in there. But hopefully you notice the first one that is adding each time is linear, straight line, right? The strain B, that's multiplying each time, it's not a straight line, it's curved because it's exponential. Doubling each time will give you that exponential curve, okay? So the type of function, the first one is straight line, it's linear. The second one is exponentially curved, that's called exponential. Now the equations. Now you could have already given me the strain equation for A because we already learned when there's a rate of change, y'all remember radii, the math cat, right? The rate is the slope, and the y-intercept is where it starts. We started with one zombie, right? So 3x plus 1 would be our linear equation for strain A. But for strain B, this is new stuff you haven't learned here yet in my class, but I'm here to tell you, since it is doubling each time, it's 2 to the power of x. X is a little x in the exponent, okay? So that's what we're going to see as the days go by here, okay? So write that down real quick, and then we want to, if you want the extension answers, I can show you that here in a second, okay? So I'll give you a minute, make sure you got the right graphs and the right equations and the right type of equations. Okay. You need to write down the right ones. I need you to check it. What's that? Right? Cool. All right, and then at the bottom, if you set each of these equations equal to your dependent value, what you're trying to find out, which was 67,000 people, okay? So if you set 67,000 people equal to 3x plus 1, you could either solve it by hand, or you could solve it the way we taught you in Desmos, where you replace the equals with the squiggle, a tilde, and you replace the x with the letter n. If you type that in, it'll spit out the parameter answer, which is 22,333 minutes to get to 67,000 people if you do a linear adding 3 each time. It's a lot of minutes. However, notice on strain B, if I use 67,000, and this is supposed to be squiggle, 2 to the n, well, if I type that into Desmos with a squiggle and the letter n, it'll tell me my parameters, n equals 16. So only 16 minutes instead of, 22,000 minutes plus. See how that's a lot different? You see how fast things can grow exponentially. It's a lot faster than linear, okay? So that's the takeaway of the extension, but I'm gonna leave this right here if you need it. And you can hold on to this, and tomorrow we're going to get into some new stuff with exponential functions.